I'm going to start with the easier of the two graphs first. And in my opinion, the easier of the two is this top inequality here. That's going to just be a horizontal line. I'm going to go down to -1 on the y-axis here, and then we're going to draw a line going straight across. Before we draw the line, though, because this is just a greater than sign, it tells me two things. First, that we're going to have a dotted line, and second, that it's going to be shaded above the line. So I'm going to make my dotted line that goes through -1 on the y-axis, so my horizontal line, and then I have to do some shading. So I'm going to shade everything above the line. So all the stuff in yellow, if I took any ordered pair from what I'm shading in yellow and I plugged it into my top inequality, it would be true. Now let's talk about the bottom inequality. This one is going to be a little bit more work to graph. Oops, I meant to use blue. We have to make a table of values. So I'm going to do that over here. And in order to make our table of values, there's only one part we have to do by hand. And that is we have to figure out what number goes in the middle of our table. So I'm going to use this little mini formula, -b over 2a. And up here at the top, I'm going to identify A, B, and C. We don't need C, but it's not really much work to do it. So A is the number in front of x squared. So in this problem, it's 1. B is the number in front of x, which is -4. And then C, which, like I said, we're not really going to use, is -1. So I have -b, which is -4, over 2 times A, which is 1. -4 is +4. And then 4 divided by 2 is 2. So 2 is what goes into the middle of my table. At this point, you're going to take out your calculator. You're going to type what's in the blue box into your y equals screen. And then you're going to go to the table. So like I said, the first step is you're going to go to y equals, and you're going to type in your inequality. And then second is you're going to press second graph, and it's going to give you your table of values. And what you're looking for is this 2, which is the number we found as our middle number, or our vertex. So we always want to go 2 points below and 2 points above that number. And then from here, I'm just going to copy down the numbers. Oops, -1 is my first one. I'm going to copy down my numbers that go into the table. So -1, -4, -5, -4, and -1. And one thing I want to point out is that your vertex, or that middle number, should always be the only y value, and then the y value that is -5, and then the other ones should be like a mirror of each other. So they're symmetric. If that doesn't happen, that means that you made a mistake somewhere. Either you typed it in your calculator wrong, or you did -b over 2a incorrectly and got the wrong middle number. So now I'm going to start to plot these points. But before we do that, let's talk about the fact that this is going to be a solid line. And I know that because it's got the bar underneath the inequality. And because it's a less than symbol, we will be shading below the graph. All right, so I have the point 0, -1. So I can already see where my two graphs are going to cross at least once. 1, -4, 2, -5, 3, -4, and then 4, -1, which is another point where the two graphs cross. So I'm going to connect the dots with a solid line, and I'm going to be shading below the graph. Now, this is a little bit weird, but I imagine for parabolas, if you imagine that you're pouring water in from the top of the graph, whatever part of the parabola that the water would touch, which in this case would be the inside, would be considered above the graph. So that means below the graph would actually be everything on the outside of the parabola. So I'm going to shade everything on the outside of the parabola in blue. And it's a little bit hard to see because it just kind of took over everything, but there are two sections where, as I was shading, you could see that they kind of turned green. So I'm going to attempt to make those sections red now. So it was this section here, just until that line, and then this section here, just until the dotted line. So those two parts that are red are the actual solution of this problem. So that's a solution, and that's a solution. Any point that we take out of those two sections of the graph, if we plugged it into both of our inequalities, it would make both of them true.